Geometry 6-5, rhombi and squares. So a singular rhombi, singular version of rhombi, okay, octopi, is a rhombus. Rhombus is a parallelogram. So if it is a parallelogram, the opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, meaning they add to be 180 degrees. Diagonals bisect each other. Now here are some things that a rhombus has that not all parallelograms have. And a square is a rhombus, as a type of rhombus. Diagonals are perpendicular, meaning when they cut through one another, they bisect each other, but when they bisect each other at a 90-degree angle, so they're perpendicular. Diagonals bisect the angles, so that means when the diagonal cuts through the angles are congruent to one another, the ones that they bisect. All four sides are congruent, not just opposite sides, all sides. So that's what separates a rhombus or a square from other parallelograms. Let's do some examples. We're going to draw a rhombus. So all sides should be congruent. This is FGHJ. And we're going to draw the diagonals. And here where the diagonals cross is K. So remember, FG, GH, HJ, and JF, these are all congruent. Now, we are going to, I want to know what is, well, let's say, if measure of angle FJH is 82 degrees, find the measure of angle KHJ. Okay, so if FJH is 82 degrees, FJH, so that's this whole thing right here, is 82 degrees. I want to know what is KHJ. I want to know this angle right here. All right, so I've got to use my understanding of triangles for a little bit here in order to figure this out. So first off, this angle right here, so here's my triangle. I'm just focusing in on this triangle here because I want this angle. I know this angle, this whole thing is 82 degrees. And since this is a rhombus, this diagonal bisects 82 degrees, so it cuts it in half. This has to be 41 degrees. So this is 82 divided by 2, right? 41 degrees. So if this is 41, this angle here, I know, is 90 because it's a rhombus, and so 90 degrees is the measure of each of these angles here. That's all right. So I know what is the measure of all of these angles put together in a triangle. It's 180 degrees. So 41 is that one, plus 90, which is that one, plus this one here, I don't know, let's just call it, oh, let's not call it X. Let's call it measure of angle KHJ equals, if I add these three angles up, I should get 180 degrees. So I'm going to add these two, that's 131. I'm going to subtract 131 from both sides. Measure of angle KHJ is 29 degrees. Oh, wait a minute. Oh yeah, I did that wrong. 49 degrees. Goodness. My brain is getting a little mushy, but all right. Now, We're going to look at the same diagram here, but we're going to change some of the measures. Fk is 5. Fg is 13. What is Jk? And then we got another one here. GH equals x plus 9. JH equals 5x minus 2. What does x equal? Let's do this one together, and then let's have you do this one on your own. So if Fk, that little piece right there, is 5. Fg, this longer piece here, is 13. What is Jk? Okay, so I've got this piece and this piece, and I don't know this piece, and I want to know this piece. Remember, these two are the same length. So if I find this one, then I find this one, because they're the same. So if I have this one and this one, this is a right triangle, remember. I should be able to use something called the Pythagorean theorem to find this one, right? So remember, a squared plus b squared equals c squared, hopefully. So if this Fg is 13, so that's 13 squared, that's the longest side, that's the hypotenuse. And then we'll say b squared is 5, b is 5. And then a squared is the other side that I'm trying to find. Okay, so this is 5 times 5, which is 25. 13 squared is 169. I'm going to subtract 25 from both sides. A squared equals 169 minus 25, so that's 144. Take the square root of both sides. A equals 12. Square root of 144 is 12. So 12 is the answer for that one. Now let's have you do this one on your own. So I know what GH is 6 plus 9. Ignore all of these other numbers here for this. This is just a whole new thing, right? So GH is x plus 9. JH is 5x minus 2. Find out what x equals. All right, so these are new measures. Don't use any of these other measures here for this information, okay? Go. Okay, GH and HJ are congruent, so I can set them equal to one another. X plus 9 equals 5x minus 2. And I'm going to subtract x, and I'm going to add 2. 11 equals 4x divided by 4, and I get x is 11/4. It's gross, but it's the right answer. All right. Now, let's do another section. We're going to talk about squares. So squares and rhombi are very much the same, but we're going to write this stuff down as well. So here's squares. Opposite sides are parallel. Opposite angles are congruent. All angles are 90 degrees. All angles are congruent. Because in a square, all angles are 90 degrees. All angles are congruent. Diagonals bisect each other, and they're perpendicular, just like other rhombi. And all of the bisected segments are congruent, so this is different for a square than other rhombi. Consecutive angles are supplementary, they equal 180 degrees. All sides are congruent. All right, so that's squares. Let's do a square example. Ooh, a proof, exciting. Just one square example and it is a proof. Given JKLM is a parallelogram. Triangle JKL is isosceles. Prove JKLM is a rhombus. So let's draw the diagram. Oof, that is not an awesome rhombus. Okay. So KLMJ. There we go. Okay. So we are going to prove using statements on the left, reasons on the right. Okay, so I'm not going to have you rewrite the given. It's already written. I already wrote it. Okay. Now, we need a plan, though. So, we have one more line to draw here. Line segment to draw. There we go. Okay, now we're ready to go. So, JKLM, this is a parallelogram. Okay, so remember what a parallelogram means. It means these sides are congruent. It means these sides are congruent. It means these sides are parallel, these sides are parallel, these angles are supplementary, okay, all this stuff. JKL, this triangle, is isosceles. Okay, so I need to prove this is a rhombus. I already know it's a parallelogram, so that's helpful. I don't have to prove it's a parallelogram. It's already a parallelogram, but that means these sides are congruent. These sides are congruent. Now, if JKL is an isosceles triangle, that means that these two sides are congruent. So if these are congruent, and these are congruent, and these are congruent, that means they're all congruent. So all of these sides are going to be congruent. And that's what we're going to say in our proof here to prove that this is a rhombus, because a rhombus is a parallelogram that has all of the sides being congruent. So let's say KL is congruent to JM. So KL is congruent to JM, we know that. And KJ is congruent, so I'm going to say this one is congruent to this one, LM. And that is the definition of a parallelogram. Okay, so I've just said this one is congruent to this one is congruent to this one. It's a parallelogram, so we know that. Now, I am also going to say that this one is congruent to this one because of an isosceles triangle. So KJ is congruent to segment KL. And that's a definition of an isosceles triangle. All right, now we are going to use some algebra here, and we're going to say we're going to plug KL in for KJ, and we're going to plug KJ in for KL here. And so I'm just going to say that K, because these are congruent, so I'm going to say KJ is congruent to JM, and then I'm going to plug KL in for KJ here. So KL is congruent to LM. KL is congruent to LM. And that's by substitution. And since I've said these are congruent, I can say that all sides are congruent. And by substitution. Now, if all sides are congruent, then I say JKLM is a rhombus, and that is because this is a parallelogram, and all sides are congruent. Boom. And that is the proof. Done. And 6-5, done.